Let's talk about significant digits for a moment. This is something that often people get hung up on, and so I'm going to explain this in sort of 3 separate little videos. But I want to take a look at a simple example. So let's say that we have a ruler and that we're measuring the length of the pencil. And so here's our ruler. And what we did is we lined it up with 0 here. I think it's important to recognize that lining it up with the 0, it is impossible to be 100% accurate. So there's already a little bit of error there. And let's jump over to the end. And here we can see that the tip of our pencil is kind of around 3.9. If we really zoom in there, we see it's actually, maybe a little bit less, but we cannot be that accurate. We're just going to the millimeter here. That's what the measurement on our ruler is. And so we're saying, yeah, we're pretty close to that 3.9 centimeters. So we can say 3.9 centimeters is the length of this pencil here. I think where significant digits come in is recognizing that 3.9 centimeters is not the same thing as 3.9000000 going on for infinity. When we say 3.9 centimeters, we are saying, there's 2 pieces of information here. We're saying that we have this measurement, and we're also saying that this is how precise it is. So if we know that it's 3.972, then we would want to write 3.972. If we knew that it was 3.9725, then we would want to write 3.9725. But we don't know that because we are bound by by the precision of our measuring device. This ruler doesn't have any smaller gradations than a millimeter here. And so the best we can say is 3.9. So 3.9 does not mean 3.9000000. 3.9 centimeters actually means 3.9 followed by a whole bunch of I don't knows. 3.97, I don't know. 3.91, I don't know. 3.9258, I definitely do not know. There are digits behind there. Anytime we're measuring something, there is theoretically an infinite number of digits there. We're saying 3.9, and then we're going to have a whole bunch of numbers that go off forever. We do not know them. And we can only know them to the extent that our measuring tool can measure them. So 3.9 centimeters, we are saying that we know the 3, we know the 9, and we don't know any of the digits after that. So everything after that is a question mark. 3.9, question mark, question mark, question mark, going on forever. We do not know these. And so going back to that 3.9, we can say that we are confident that we know 2 digits and 2 digits only. The fact that we know those 2 digits means that they are significant. They are significant digits. So how do you get more significant digits? Well, if you want to get more significant digits, you need a better measuring device. So I don't know, if we had a laser and we used a laser to measure the distance here of this pencil, like from one end to another, we could probably have many more digits beyond that 9, and now we have a measurement with more significant digits. But with this ruler, 3.9, so we only have those 2 significant digits. Your measurement can only be as precise as your measuring tool, and you cannot and how precise your measurement is going to determine, what of those actual digits do you know? We only know the 3.9, the 3 and the 9, 2 significant digits. So anytime we're measuring anything, we're recording essentially how precise our measurement is in the measurement itself, and that is those significant digits.